Good morning, everybody. Shall we start? We only have 1 hour and a lot to do. I see we have 82 people online, so that's a good turnout. Thanks everybody. Thanks so much for joining. My name is Kirsten Hunt. I'm a senior mining specialist with the World Bank, and together with my colleague Daniela, I co-lead the Climate Smart Mining Initiative, which is one of the co-hosts of the webinar today. Before I get into the content, just a few matters of housekeeping for everybody. The participants will all be muted during this webinar, but please do send us questions through the Q&A box if anything comes up during the presentation about which you'd like clarification, and we'll try to get back to that at the end of the presentations and answer your questions. For the program of today, we have 3 excellent speakers, and we would like to give them the floor, be going in depth into the discussion. So we will try after each presentation to quickly answer any questions for clarification, preferably those that have been written in the chat function. And at the end of the session, we will have a good time to really go in depth into the discussion. So please save all your questions about the whys and the hows and the what's next for the end of the session. If you do ask a question, please also in the chat, please introduce yourselves as well, your name, your organization, and where you're connecting from. And lastly, this session will be recorded, and the recording and the slides will be sent after a few days to you through email. So you'll have a chance to look back. So that's the housekeeping part. Then on the Energy Storage Partnership, which is the host and the organizer of this session together with Climate Smart Mining. For those of you that do not know, the Energy Storage Partnership was convened in May 2019. It comprises of the World Bank Group and 35 partners. And the ESP Secretariat is run by SMAP here in the World Bank as well. And the objective of ESP is really to bring together international organizations to help develop safe, sustainable energy storage solutions tailored to the need of developing countries. They do so by connecting stakeholders and sharing international experiences in deploying energy storage solutions around the world. ESP helps bring new technology, regulatory and capacity building solutions to developing countries, as well as developing new business models that leverage the full range of services that storage can provide. ESP takes a technology neutral approach and helps to expand the global market for energy storage, leading technology improvements, more integration of renewable energy, and accelerating cost reduction over time. ESP has now completed 1 year, and we held a virtual meeting with all partners in the second half of June 2020. I suspect many of you participating today were there. In the first year, 7 working groups were established to work on power systems, test beds for knowledge dissemination, development of testing protocols, flexible sector coupling, decentralized energy storage solutions, procurement frameworks, and enabling policies for energy storage, and the reason we're here today, reuse and recycling. The Working Group 7 on reuse and recycling was co-led by the Climate Smart Mining Initiative. And in the presentation coming up, John Drexage will showcase the members of the working group who have all added a very valuable contribution to the research that we will be presenting. The different ESP reports will soon be published, including the one that we are presenting today on reuse and recycling of lithium-ion batteries. If any of you here today are not yet a member of ESP would like to join, please do get in touch with us. The contact details will be on the slides later on. And very quickly, as I mentioned, this particular work is a collaboration between the Energy Storage Partnership and the Climate Smart Mining Initiative of the World Bank. Climate Smart Mining is an initiative that supports the sustainable extraction, processing, and recycling of minerals and metals needed to secure the supply for low carbon technologies by minimizing the climate and environmental footprints of these technologies throughout their value chain. So the idea is really we're all going to need lots of minerals and metals for clean energy technologies, amongst others batteries, which is why the reuse and recycling of batteries is so crucial for us for a sustainable value chain. So we're very keen, we're very happy we could participate, and we're very happy to support this work. With that, I think I have spoken enough, and I gladly give the floor to our excellent speakers, starting with John Drexage. John Drexage is a member of the Climate Smart Mining team and is the coordinator of Working Group 7. John has worked on issues related to climate and resource development policies for over 25 years with government, multilateral organizations, research agencies, civil society, and the private sector. I'll introduce our other speakers as we get to them. With that, I happily give the floor to you, John. Thanks very much.
Thank you very much, Kirsten, and really appreciate the great turnout that we have here. I'm noticing now up to 118 people, so very, very much appreciated. The first thing I'd like to emphasize is that this report, and it will be released, I would expect, within the month. We don't have any specific dates at this point, but it's reasonable to assume it will be released within the next few weeks. It was very much a collaborative effort globally. What we've done is, in the first slide, list the different institutions who have provided contributions. I truly played the role as somebody, as a coordinator per se. My background and specialization is not in the battery area, but basically what I enjoy doing and what I really appreciate the World Bank giving me the opportunity to do is I like to play the role, as I put it, as a policy launcher. And what's been happening with this issue is such that I think we really have to grapple with it and get our heads around it before it gets too late. But these are the different institutions that are part of Working Group 7, and each one of them played very strong roles in making substantive submissions to the report. And I just want to note that and thank them for their contributions. Tariq, on to the next slide, please. So the whole role of developing countries in a circular economy is becoming an increasingly important one, not only for managing local environmental impacts, which is incredibly important, of course. We've had issues in the past and continue to with cobalt and other issues in ensuring that there's a good governance systems and sustainable extraction practices in place, and that represents a significant challenge. But that, in fact, as we're going to be going forward, it's becoming clearer and clearer that all options are necessary for us to be able to reach as an aggressive goal as 1.5 degrees is what countries have agreed to under Paris. And all hands need to be on deck, and that includes very much the reuse and recycling of these lithium-ion batteries. And I think it's very critical that we start developing a new framework for developing country engagement when it comes to the green economy and the local economy. Most of the time when we've looked at this in the past, it's looked at from the origin side or the extraction side of events. Developing countries have also been victimized in the past by very unsustainable waste trading practices or waste collection practices, et cetera, e-waste, et cetera. And we want to make sure, as the lithium-ion industry is going to be exploding, we expect over the next 10 to 20 years, that we deal with this problem ahead of time rather than after. So Tariq, yes, please, the next slide. Kirsten already mentioned that this is an initiative of the Energy Storage Partnership along with the Climate Smart Mining. And we have support from a number of companies, Rio and Anglo, as well as governments, the Dutch and the Germans, who are helping to promote the climate smart mining concept. You see that there are 4 pillars here, and the pillars really relating to reducing material impacts, adoption of a circular economy, and reuse, recycling of low carbon minerals is an area that we are focusing on in the mining initiative. So this is in addition to being very much part of the Energy Storage Partnership, an initiative of the Climate Smart Mining Initiative as well, which I think is a really important message about collaboration going on between the two constituencies, 2 areas. Okay, Tariq. So make the case for why we are focusing so much on lithium-ion batteries, when in fact the developing country penetration of those of that product is not so great at this time. If we're looking at directions, and we're looking at just now the extreme, what we're going to see is a huge increase in demand. And this is right across, this came from Bloomberg, but these kind of statistics in terms of the anticipated demand for lithium-ion battery it's consistent with what others are projecting. You just have to recall a couple of days ago, the net worth or the net value investors have provided for Tesla is greater than any other car manufacturer in the world, which is a remarkable thing when you sit back and think about it. given that the actual production of numbers is still much, much lower than any of the other main car manufacturers, Tesla has more money invested in it than any other car manufacturer. So that really is what's driving these projections. I know that there are many who feel like, oh, what about hydrogen? What about solid state, or many other kind of battery options? These all have they are all there are opportunities there, but from the scenarios that we've been looking at, from IEA, from IRENA, and from others, seems to indicate that really what we're going to see most above all is a real strong increase in demand for lithium-ion batteries. Okay, Tariq, go to the next one. And then, so we use the circular economy approach to recycling and reuse within this document. So recycling, we really focus on the retrieval of minerals, metals for use in a wide range of contexts, not only it's not intended for the specific reuse or repackaging of that product, but actually taking the metals and materials out and using them either in other contexts or using them to enhance your critical minerals, metal strategic supply. This is something that particularly large economies, large developed economies, are the reason why they're focusing on recycling. The current practices, particularly pyrometallurgy and hydrometallurgy, have environmental complications. There are different options being looked at in terms of cleaner options. There's a direct recycling option that's coming out of the NREL. Also, I think it's critical that we ensure that a new e-waste regime is developed for lithium-ion batteries in developing countries. We really have to change the narrative from the dumping ground to a sustainable platform for EV battery recycling industry. And that could be a very, very, important economic activity going forward. Reuse, on the other hand, and I use reuse and repurposing in the same context. I know other articles have not, and there's lately been, I've seen a division of definitions where reuse is for explicitly for the same purpose as the initial purpose, whereas repurpose is for other purposes. So I don't want to get into too much of the details on this. We're focusing on the repackaging of e-batteries from their first life. And in particular, in the case of lithium-ion batteries, from their first function as in the car industry to a stationary storage system provider. And that if properly implemented, it is definitely more the potential to be both environmentally and economically more benign. I'm not sure what happened, Tariq. I just lost the screen for some reason. Oh, there it is. Good. And then the challenges that we have, though, is the fact that unlike the lead acid battery, there's at least, even amongst lithium-ion batteries, 6 different kinds that are being used right now, which makes for very complicated practices when it comes to trying to repackage and repurpose them. Finally, in terms of the impact on extractive industry practices, when we released a report in 2017 and now subsequent to that in 2020 that looked at the mineral intensity of the green revolution, that in fact there was some concerns expressed about this being simply an apology for mining more, and that there needs to be more focus on reuse and recycling. Both in this report, of course, we're doing that, but even in the other report, the 2020 report, looked at recycling and how much it could impact on extraction. And while it could reduce some of the extraction, it certainly cannot substitute for all of it. And that we will need both sustainable extraction and sustainable mining, as well as recycling and reusing. Okay, Tariq, I can go to the next one now. Thanks. So in terms of some observations on the current status, the opportunities, I think, as I was mentioning, the strategic value of climate action, minerals and metals, many of these do play a role in a broader strategic value sense, and that is particularly important for the larger economies. So Japan, for example, has a very strong urban mining initiative, as does South Korea, and they do it for those reasons. Developing countries up to this point have not so much been thinking in those terms. To the extent that these things are going to be reused, I would expect it would be more in the reuse or repurposing profile. One thing that we can mention, though, and we did a regional breakdown of the number of activities related to the recycling of lithium-ion batteries and the state of regulations and standards, et cetera, is that with the notable exception of China, the steps that have been taken in terms of building a lithium-ion transition circular economy approach for lithium battery irons is virtually nowhere. We're really starting at ground zero here. Challenges are relating to the design, which is the fact that there are, as I mentioned, already 6 batteries in operation with very different design and very different elements. And so that makes for its challenges. Collection in the first place, how do we go about setting up appropriate collection centers, and what is the best way to do that, particularly given the case at this point in time, we don't have a huge supply of second life lithium-ion batteries. The capacity that is required both in recycling and in repackaging, and the training and skills developing for that. Coordinated standards and regulations. We don't really have, with the exception of China, we don't really have many. There are some, there's certainly the standards that have been developed in some of them in the past. We also have some regulations that have emanated from some of the countries. What we don't have to any degree is any kind of coordination. And then, of course, another big issue is around liability and the extended producer responsibility, and ensure that that sort of gets developed and integrated in the industry. Okay, the next one, please. So in terms of the conclusions of the report, I think some of the research that we agreed that needed to go forward, and once again, I want to emphasize that this is stuff that was the inputs directly from the research organizations that were part of this initiative. How can we best integrate and balance competing considerations in the design of the battery? So for example, you have the safety, health and safety considerations, you have the recycling capacity, but then you also have the economy. So what are, to what extent can we integrate all of these considerations so that we could bring it down, the number of systems in place? What are the most appropriate and effective kind of collection systems? What can we learn from lead acid batteries, particularly in that regime? What can we expand the potential repurposed battery packs? One of our other working groups looks at different uses of the lithium-ion battery in different contexts, and batteries more generally. And I think looking at the capacity of these battery packs beyond microgrids and home support would greatly expand its utilization. And then finally, developing comprehensive indicators. We like to bandy about the term circular economy. I think we need to become a lot more concrete in terms of what we mean, and throughout the entire, from extraction to the final dispensation of the product, exactly what are the different indicators to indicate that in fact those sustainability requirements are being addressed. And when we're saying sustainability, that is not just a code word or equivalency to environment. It is also very much dealing with social and equity considerations. In terms of policy recommendations, I think going forward, governments should first perhaps look at some of these areas is awareness raising for consumers, producers, and recycling. I think that's the first step that needs to start taking place and start getting ready for that. Developing some regime that provides incentives and penalties towards promoting full recycling. What are some effective business models? I think one of the interesting issues is around how can we most ensure that in fact this will become a profitable and sustainable enterprise. One of the areas that, for example, needs to be addressed also is battery management systems, and making sure that we're able to track what happened in the first life and use that in terms of informing the development and redeployment of the second life of battery as effectively as possible. Framework for training and upskilling, we need to develop programs for that. And then finally, beginning to think about developing an international cooperative regime for future regulations and standards and reliability provisions. Some people have talked about Basel being an appropriate forum. Others are looking at other things where you're looking at it more from a strictly products rather than elements sector. In any case, I think we have to start really seriously looking at developing cooperative regime around this. So going forward, for the last slide, Tariq, if we might, thanks. For priorities for developing countries, developing systems for integration and effective management. How can we balance those different I think the three critical considerations is the health and safety factor, the recycling reuse capacity factor in the competitive market, and how can we more effectively integrate those into developing a more comprehensive and coherent design structure. Circular economy indicators, again, what I had talked to before, developing regimes around collection practices, enhancing the economics, building the business case, regime building, that is strengthening standards, regulations, and liability provisions, extended producer responsibility. And then finally, I think going forward, we also need to look at more effective cross-working group coordination. So we already have working groups looking at safety, at warranties, test beds, multiple uses of the lithium iron. I think recycling and repurposing and repackaging of this all play a role in each of these. So we need to look at ways in which we can effectively integrate them with each of these programs. I just wanted to mention, and Matti will follow up on this immediately after this presentation, that we will be partnering with the Global Battery Alliance and Faraday Institution in developing roadmaps for deployment of second life batteries, lithium-ion batteries in Africa. And he'll go into detail a bit more about that. And I just want to conclude that, you know, one of the exciting things that I find with many of these initiatives is that how it opens doors. And one of the interesting things about this initiative is how it's opened the door between the energy extractives and climate communities. And I am hoping that of the now 130 participants in this video, or in this workshop, that this has begun to this has initiated a strong dialogue amongst these three constituencies, which is going to be very critical if we're going to be able to go forward in an effective way on whether it's a climate issue, whether it's an environment issue, or whether it's an economy for developing countries issue. Thank you very much. Kirsten, I'll hand it back to you.
Thanks so much, John. I did not see any immediate questions in the chat, unless anyone has a very urgent question for clarification. I am going to go to the next speaker, and then we can deal with the questions afterwards. So our next speaker is Matti Stanislaw, who is the interim director of the Global Battery Alliance. We're very happy to have you here. The Global Battery Alliance is hosted by the World Economic Forum and pursues a battery value chain that is socially, environmentally, and economically sustainable. Matti served also as a senior political officer for the Obama administration, serving as the assistant administrator of the US EPA Office of Land and Emergency Management. Matti, thanks so much for being here with us today, and I hand it over to you.
Okay, thanks, Kirsten. And Tarek, if you could go into the next slide. So just a little bit about the Global Battery Alliance and its vision. There's a report that was issued in September of last year. Tarek, next slide, please. Tarek. We did a report consulting with stakeholders, doing an analytical study, partnering with McKinsey, looking at data modeling. And what we identified is a potential role of batteries to be a major driver towards the Paris Agreement, reducing the footprint of battery production, again, focus on lithium-ion batteries by 50%, but it to drive the reduction of the transportation and power sector by 30%. This is so both grid, off-grid, as well as the transportation sector. To do so, what we identified is a critical importance of increasing battery demand by 35%, and components of enabling that 35% demand increase is reducing the cost by, we projected, 23% by 2030 by optimizing circular economy levers. This includes optimizing first use, repair and refurbishment, optimizing utilization of batteries, from vehicle to grid applications, as well as second use applications, and optimizing product quality recovery of materials from batteries. And the last very important aspect is safeguarding human rights and economic development. The battery value chain, particularly cobalt, the most acute, significant issues about use of child labor, forced labor, ensuring safe working conditions. So the report concludes that To realize this, we have to scale the battery value chain 19 times by 2030. And we identified a number of specific actions. One is it's crucially important to enable data transfer. This is taking advantage of digital technology about traceability, about verification. So we're advancing something called a battery passport to scale, for example, first use, second use, and recycling. And we expect to roll that out, the first version of that, later this year. Another action that we're taking is transboundary regulation. We'll be publishing a paper in September that looks at the current state of transboundary regulation and how we can adjust that to really distinguish transactions for repair and refurbishment for first life and second life from waste management activities. And as it relates to this topic, we really talked about the opportunities of scaling reliable delivery of renewable energy and addressing energy access in emerging markets, both in off-grid and microgrid applications, and reducing the gap of people without electricity by 70%. And we identified the potential use of second use of EV batteries, also designed for purpose down the road, but also in doing so, make sure that and the outcomes of health, shifting from dirty fuel to clean fuel to renewable energy, economic outputs of enabling more reliable energy, and the educational outputs. And crucially important is ensuring the end-of-life management of batteries for all battery chemistries, so we ensure that a full circular economy is put in place up front as part of an energy access system. Next slide, please. Tarek, next slide. Tarek?
We seem to have lost him.
No, just a second. I'm reopening it. My bad. Problem with the PPTs. We're back.
So while you pull it up, I'll just start then. We have partnered, I'm grateful to partner with the World Bank, with the Faraday Institute, with the Danish Ministry, there you go, the Danish Ministry of Foreign Affairs, GIZ out of Germany, working with the United Nations Economic Commission from Africa and the Africa Circular Economy Alliance to put in place a roadmap of how do we really deliver energy access in Africa while ensuring the protection, the end-of-life management. So we're just about embarking on the advancement of that, beginning with, I would say, a report that pulls together the existing analysis done by World Bank, analysis done by Faraday Institute and others, and identify what others have already identified in terms of energy access opportunities and what are those key barriers to doing that, and what are the underlying conditions, policy conditions, financial conditions to realize that potential, both in terms of energy access delivery, but also ensuring end-of-life systems to ensure end-of-life both short and long term. And what we envision is issuing what we're calling a roadmap of recommendations for realizing that, again, both in short term. What we expect to do is to do really deep stakeholder consultation later this year. We'd welcome anyone on this call who wants to participate in that. We also expect to consult with the ministries of African countries who are interested in this issue and make sure that this report is co-endorsed, co-supported by the leadership, both at a ministry government level, but also at a stakeholder civil society level. So we look forward to working with our partners here and the stakeholders to make sure that this roadmap is meaningful and can realize the outcome of energy access as also protective for communities. Thank you, Kirsten.
Thank you so much, Maddie. That was very informative. I see some questions are starting to come in, so that's great. But without further ado, I wanted to give the floor first to our last speaker, Mkhulu Mati, I'm very glad you managed to join us. I understand there were some technical challenges. Mkhulu is the program manager at the CSIR in South Africa for the Smart Utilities and Energy Storage testbed programs, with current research interest focused on the synthesis, characterization, and application of nanomaterials for energy application, like fuel cells and batteries. Thank you so much, and over to you.
Good morning, good afternoon, and good evening. I think we just witnessed the need for energy access that's reliable and consistent. We had load shedding, but I'm back online using my cell phone. So next slide, please. Next slide, please. I thought I would give a background by talking about the Industrial Development Corporation, who with USTDA commissioned a study regarding the South African energy storage landscape. And they identified use cases of bulk energy services, ancillary services, grid infrastructure services, customer management services. And subsequent to that, they were identified because of the purposes for which they would be used. So our national utility company has embarked on a storage facility for lithium-ion battery that they got from BYD. And then there's vanadium redox flow battery from Bushveld Energy, zinc bromine from Primus Power. One point with vanadium redox flow battery is due to the abundance of vanadium in the country. And as Mikhail indicated yesterday, there's the need to beneficiate local materials and to create jobs. So the reason why ESCOM has that testing facility is to integrate storage at convenient points on the national grid to ensure that there is finally complete energy access. And when you're looking at companies like Eaton, ABB, and others, they have microgrids where they use the secondary EV batteries. Next slide, please. Next slide, please. Okay, and so on the next slide, you can see that at the CSIR, which is a National Science Council, with partnership with the World Bank and Vito in Belgium, there is an intent to establish a storage test bed in the south, because up north we have Morocco. So quickly, why we have that, it's capacity building and knowledge sharing that is focusing at the end of the slide. And the major African market battery storage hurdle is the skills gap and lack of policy commitment, and also end of life, which is recycling. So in conclusion, one can say there are unlimited opportunities because we can make better materials using the minerals that we have, and ensure that the local energy storage is inexpensive, dependable, and sustainable. And finally, we will include artificial intelligence in energy automation and trading. Thank you.
Thank you so much for that. That was very informative. I see some questions coming in. I suggest I'll just go over them in order. There's a few questions in the chat as well. It would be helpful for every one of you have questions to submit them through the Q&A. That way we make sure we don't lose them, because in the chat they tend to get lost sometimes. Let me start with the first question, which is an interesting one. Shouldn't maximum, from Julia Badeda from AOB Wind, shouldn't maximum recycling quota be in the own political interest of a nation, as it will be one important source for resources in the future? Any one of our speakers who would like to answer that one first?
I'll take a crack at that. I think tracking the recycling of data, recycling of batteries is important. A quota per se does not work. and it's proven not to work, you need to put in together systems to collect, to repair, to refurbish, and recover those materials, as well as the regulatory and financial systems to advance recycling.
I would add that it really depends on your specific circumstances, and that if you're a resource-rich country, for example, that has, let's say, for plenty of cobalt or lithium or others, a short-term perspective might think that perhaps recycling wouldn't be in your interest, because you would be more interested in trying to sell that primary product as much as possible. And we just need to be careful that when nations are making their choices around this, they understand where their resources are, where and what they can manipulate to the best of their abilities, but that recycling and repurposing in whatever context still plays a very critical role.
I would say that recycling, apart from being good environmental stewardship, it ensures increased life of resources and security of supply of materials. Because we know instances of technological dumping, so where we are going to synchronize standards across, we have to influence policy that talks to recycling to ensure that there is going to be enough material to supply the batteries or any other systems that we're interested in. Thank you.
Thanks. There's the same from the same person. With which lifetime extension of a battery due to second life use are you calculating? I think that's for you.
Well, normally I'll take a crack at that and say normally the batteries are supposed to last about 15 years. But when a car is purchased, the battery is aimed at maximum about 8 years. And then once it's no longer in the car, it is envisaged that it can work for about 7 years or so. So the problem is how to do a good battery management system that ensures that it is tailor-made or engineered to a specific use. And then it also affords the opportunity to test new chemistries in these batteries with the permission of the OEM.
Yeah, I would just add that based on the data of EV applications, so EV batteries become unusable for EV purposes at a very high capacity level, roughly about 73 to 75% storage capacity left. So you have this asset that is underutilized, significantly underutilized today. And the whole opportunity of second use batteries is to utilize that storage capacity for storage purposes and not on EV purposes. Also, we need to figure out the economics of how we share the benefits and share the risk and the liability to really scale up second use.
Thanks. Then from Ignacio Cruz from CIEMAT, what is your opinion about the future influence in the recycling strategy of development of self-healing functions?
I'm sorry, say the last part, Kirsten?
Self-healing functions.
Self-healing.
About the future influence in the recycling strategy of the development of self-healing functions. Anyone?
I guess I'm not clear what that term means, but I know there's active conversations about design for disassembly to repair and replace at a cell level, at a component level. So that, using data to track degradations at a sub-pack level to be able to replace that. So those are some of the conversations that both from a design for disassembly as well as data to enable the optimization of batteries. So.
Yeah, that's called the battery management system, and very critical, as I understand, to have a very robust system for tracking that in order to ensure that the viability of second life batteries.
Okay, I have two questions from Ahmed Mehdi that are more linked to the mineral side of things. Firstly, how successful will direct recycling be? And I'll give you the next one right away, because then you can maybe integrate it. And the economics of recycling is also impacted by a long payback period and applied value of the recovered raw materials. So how do you think the economics of recycling will be impacted by the raw material price outlook?
So I can try the second question first. It will have a huge impact on it. And in fact, the relatively low price in terms of cobalt at this point in time, and lithium is right at that point as well, from what I understand, isn't making it economic to either recycle or repurpose. That's just part of the problem in terms of launching this initiative, is what is the actual, the price of the metals has a huge role in playing the viability of recycling and repurposing going forward. Because at this point in time, you run the risk of recycling, and the whole practices and economies involved with it is such that it turns out to be more expensive than the primary extraction of those materials. So it plays a huge role. Direct recycling, I don't know, Matt, are you there from NREL? Because he's the one who is providing some information on that, and he would be the one to best answer that if he can. I'm not sure if he can do it via text or if he's here live. He may not be. He is in Colorado, so we would be asking him to get up at 6 in the morning. So I'm not sure, but he would be the fellow who could answer that.
Well, if I may give it a step also.
Oh, of course. Sorry, McCoy.
Regarding successful recycling, I've been told that Nissan Leaf had in their plans that at the end of life, they'll be able to recycle their cars. And I've been told that they claim a success of about 80% of the components that can be reused. And I know that around Germany, they have programs that are looking into that. So the success of recycling becomes where there is policy, but where there is facilities and skilled people to do it, and the market that is able to use all the materials that are put from that recycling.
Yeah, if I can add to that on the economic side. So there are two components that address the economics of recycling. There is the recycling functionality, there's a technology side, there's a whole processing, testing, and segregation. So when we've done consultation with recyclers, what they would say, because of the diversity of chemistries, having data of the chemistry categories up front would reduce the back-end cost of reducing recycling. The other, crucially important, is the quality of secondary materials recovered. The biggest impediment of pricing of secondary materials is the quality of materials. So currently in the globe, and doesn't really limit it to battery materials, we have a imperfect recovery systems. They have too many impurities in the materials themselves to be priced as a direct secondary feedstock. So what we need to do is optimize both the data side and the technology side to recover that quality of materials. So regardless of the commodity price of the raw materials, we need to at least equalize the playing field so it's competing at the same level.
Maybe lastly, I would say lessons for the question, what Maria said. When you look at the lead acid batteries, they have affected the quality of their recycled materials. And I think with the maturity of lithium-ion battery recycling, there will be improvement in the purification of the quality and the use of the materials that are going to be made. So we could argue and then say, maybe the purity is needed to be higher in portable electronics, but not so much in stationary storage. So that is something that can be looked into the future.
Thank you.
First, yeah, Chair, I just noticed from Jesse Gersten, there's a very connected question, and if maybe we should just quick address that too, just to note
Go
it.
ahead. Okay.
Yeah. So forgive me. I don't know if this is a woman or a man, but there have been reports that the economics of second life batteries is challenging due to the continued drop in prices of new batteries. And yet, from a climate and environmental perspective, second life batteries are an essential step. What is needed in order to ensure that the second life batteries do not get priced out of the market? That's essentially what we're trying to address here. And that's exactly the kind of open-ended question that we need to address as we're going forward. Do we